Okay. Um, um, how do we even format the estimate? And what's interesting is I've talked to a lot of colleagues quite a bit about estimating philosophy and theory and things of that nature. And and Bob, I know you and I, Bob Morelli with Turner Construction, is joining us today. A great theorist in estimating, and has been on the San Diego airport and leads that estimate. It's I think 3 or 4 billion now. And estimating, we spend probably a majority of our time um, finding the information, examining um, the information, formatting. How do we want things to be formatted even before we place the actual price? So the actual price is going to be secondary to formulating the constraints of or the actual definition of every line item is where I think the challenge is going to be. And um, I said constraints, but I'm talking. I said that by mistake. I meant criteria. And so what I'm excited about today is that we talk through. I'll show you a couple of master plans, but the good thing is that I think today is that we kind of review what Jabu showed last meeting and maybe the picture of the master plan. And I can show a couple examples of master plans that we get for hospitals. And I don't know, um, Bob, you may have a couple examples too for major projects, just a quick look-see, and that would be for the non-estimating folks that are on the call. And then what I'd like to do then is to finish out the rest of the time on not necessarily how we break out the estimate into sections, because that will be absolutely part of the task, Um, but what questions do we ask? How do we formulate um, when we have a master plan and we have information starting to become mature, and we're starting to get more and more information and building a case of probability of what the future design is going to be. How do we what type of questions are we going to ask? What type of interaction is the estimating team going to have with the designers, with the engineers, with the folks that are working on means and methods and technology, and how that interacts from system to system, which is obviously, we all know, we're all theorists and practitioners on this line or on this call. So we all know the complexity of which we're dealing with, probably in humanity, nothing more complex. So we understand the enormity of what we're trying to solve. Well, with that comes, how do we communicate as an entity trying to put costs together? As we all know, those of us who are estimating practitioners, we all know it's about the questions we ask. And and when when is it the appropriate time to ask? And are we asking something that is too detailed in a timeline? Are we asking, are we, how are we going to approach understanding something in a level that is still many years out, and they still may be formulating the technology for that? This is a huge challenge. But I think all of us on this call would agree and chime up if you think not. This is solvable because we deal with this here on Earth for very complex projects. We have to come up, and again, this is the benefit for folks that are in the aerospace and maybe not an estimating realm. But in estimating, we are expected to come up with costs before design is complete. We have to have a complete picture. And it's funny, I see the estimators that I can see on the page, they're smiling and shaking their heads, and because there's a saying as if not us, then who? And so the enormity of the information, and I think is something that we have to think about. Now, up to this point, for a year, we've been really establishing theory and exploring like return on investment problems, and and how are we going to code it, and how does the information flow, and how do we talk to the different types of models and things of that nature. But now we're and that's still very important, obviously, because this is how that information and how we actually put let me and how do we actually take that information now and move it through the sophisticated theory process of a two-way flow, and how do we make sure that we are at and we're calling it a absolute absolute minimum variance to predicted state, which is trying to get as exact as possible of our cost and time. All right, so with that said, it's not taking anything away from the theory, very important. But now we have to think of the application side of it, which is how do we apply this now? The theory will take time to prove, the theory will take time to dissect and work through. But now we have to come up, and Jabu set us on this with Johns Hopkins Applied Physics Lab. Set us pretty early on the journey of like, look, if we have a master plan, how would we price that out? How would we break it out? How would we establish a way that we can organize different components of the master plan, and have some sort of a organized understanding of the theory of cost and time. So I'd like to kind of pause there, and I can bring up some examples of master plans for complex hospitals, so you can kind of see how that looks here in earth construction. Just again to give a context of what our conversation will be today, which is again, what do we ask? How are we asking questions? When do we ask the questions? How do we fill in the missing gaps of technology and systems and things of that nature? I'm gonna pause just real quick, and I want to bring a caveat in. The means and methods of any estimate. I think we all on the call that are estimating practitioners on large mega projects, we all know that means and methods could make a very bad day if we don't get that right, because material counting specific things, that's the easy part. We call that the first problem, or estimating physics. It's the peripheral, and I'll give you an example. Moon wriglet. If we don't account for means and methods on how we're dealing with the wriglet, which has electrostatic charge, and it will destroy mechanisms because of their shards, essentially, that is like little microscopic razor blades, and things of that nature. Of course, we have lack of pressure, and we have no 1/6 gravity, and on. But these two are things that we have to think about as systems are estimated. But step one is formation. How do we format the estimate so we have a structure of an organized flow of predictability on our estimate. So I'm going to pause there and break for any comments or questions, and then if you think it is if you think it would be productive, I can show a couple of master plans for Earth mega hospital, one in particular, and how that crossed over to estimate. And then maybe Bob, I don't know if you want to show maybe a master plan for an airport or something like that. That's up to you. And then Jabu, I thought it would be a good idea if you could just maybe just show just that one that master plan. It was a notational, so it's a theoretical master plan, but it's a good start. Um, if that works. Are we good? Sorry for the long setup, but I think it's important to get context um, and get everyone kind of on the same page. Any comments of what I said?
Yeah, go for it, Paul.
And
Go ahead.
Paul, just very quickly, I'm not ready to present anything today, but next time around or something, I can.
Yeah, sure. I know I just threw this at you, so that's fine. It's great to have you on a call.
Thank you.
You're an amazing thinker in the realm of estimating philosophy and theory, and you're on very large projects with Turner Construction. And thank you for joining the team. I was so happy when you said you're in. Okay, so I want to pause there. Are there any comments before any input? Agree, disagree? Old now?
Well, if I may, just a couple of notes I was writing while you're talking, Paul, and my sound cut out for a few minutes there, so I missed some things. But when you're talking about how to format, and my philosophy over the years I've been doing this, and it's been quite a few, is what I've come to say is I try to mold the estimate to the face of the project, and that's a metaphor really, but it's
Yeah.
it's meant to come in with a blank page, find out what the breakouts are, find out what the important factors are, get those adjacencies, start to identify, start lists and stuff, so that when you set up your format, you're set up to serve the project. And that has served me well over the years. And I like to talk about it that way. And then the point of how to communicate, my simple answer to that is early, often, and transparency works.
Mhm.
So that's the only thing I would throw in from my point of view.
Yeah, I think that's very warranted and in line with the discussion today. My hope is that when Jabu, can you hear?
Yes, sir. Howdy.
Thank you. Howdy, thanks for joining us. Would you be able to show that the presentation you did last time, which was really great, and just show that first, because Anne's, she had a class she had to cut out, so she would usually do this. But if you could show just the
Yeah,
notation,
the network diagram.
Yeah, perfect. Let me see here. Let me make sure that just a minute here. I think I have to get you multiple shares. Okay, you should be good.
All right. So, good afternoon again. Thanks for the opportunity.
Oh,
My
it's great.
Jibu Abraham with the Johns Hopkins Applied Physics Lab. Helped to facilitate the excavation and construction focus group with the Lunar Surface Innovation Consortium. So I had shared this presentation previously. In it, we go through our master planning process. We're really developing inputs that would inform recommendations to NASA and industry on what a site agnostic lunar base could look like. There's a lot of folks helping both in industry, academia, and government. Mark Hilberger is part of the team, and lots of folks on this call had seen this presentation previously, so I'm not going to go through the full details. I believe there's a recording of it as well.
There is, and also Jabu, this is listed in the data room, and Ann Liu is the information specialist. And if you don't have access to the data room, which the folks on this call should all have, because it's email sensitive, so just anyone can't get in there. Your presentation is listed on there as well.
Right. Yeah. And as we think about the moon and potential bases, what they would look like. We're starting to construct a couple of use cases or anchor points, and you can see kind of the evolution on a continuum where we would have functionally the moon as an expeditionary base for initial testing, where you would have some unpressurized rovers, human landers, a small ISRU pilot plant. And as you expand that, the moon could serve as a gas station for future exploration of the solar system. So it could be an outpost with O2 production, since the regolith, the surface of the soil on the moon, is about 40% oxygen. You can decompose that into constituents to support humans, as well as a key constituent for propellant on a launch vehicle. So, but to do that, you need an order of magnitude more power. So there's more infrastructure demand. And then as you go beyond that, if you wanted to, I'll call it a 24/7 persistent presence on the moon with O2 production, then you would need additional resources. So we're still working on what this would look like. I'm leveraging heavily a paper from IAA and for this model here. But that's used to inform, as we think about this anchor point, a permanent lunar base. Some of the assumptions, ground rules, assumptions, and constraints for that is we're assuming this is 30 years out. There are about 50 humans there that we're supporting. There are a number of activities from operations, science and exploration, mining, and transport, and there are several technologies there that that are available to us. So from there, we start building out a network of inputs and outputs for each of those infrastructure elements. So we have 50 humans. You have the ISRU plant that would convert the regolith into oxygen, the power distribution for that, a greenhouse, a spaceport, and then a couple of other nodes. So, Paul, I believe this is the
Perfect.
diagram you're referring to.
Yeah, exactly. Go to the next one just real quick, and slide 21.
This one?
Again, yeah. So things like this, and even the questions, but this type of information, I think we're moving into a phase that are going to be really important. And one of the and the purpose, I think, or the main goal.
Paul, can I caveat all this? So this is a suggestion, a recommendation. Yeah. This is a starting point for conversation. So these aren't necessarily requirements. This is an opportunity for conversation between a number of different stakeholders. So on the left, you can see some recommendations for performance requirements for the habitation node, and this would inform future requirements development.
Sure. So this is perfect, and I thank you for that context. But I think that's very important. You said something very important, which communication. And as information comes out, to be able to as information is developed and matured, to be able to have an estimating structure that's agile and that can change to the way that technology or that process is going to be key through the process. And that's kind of where the theory is has settled. So knowing this, as and this is very good information. I think Fred Collison with RNS, he's one of their main electrical estimators. Yeah, thank you. Is one of the main electrical estimators. When he's looking at, as we mentioned, like the yellow data points here that you have on there. These would be driven because it's if then, what if, how does it tie downstream? And so as we have one piece of information, even though it's not there, it's going to cascade on throughout a very detailed estimate. And part of the theory that I think we all need to be aware is that we need to start, it's counterintuitive, but if we want to be accurate, we need to start with as much information in the estimate, even though we may not know all the information, as we would towards the end. So it's sophisticated at the very beginning. And this is very parallel to new types of experimentation that's going on here on Earth with coming up with more accurate estimates. If I may, I think it may be helpful if I show maybe a master report from a very major hospital. It's a public hospital. It's UCSF. I'm not going to show all of the detail, but just to give you an idea, what type of information do we get on hospitals? Now, this is a hospital campus. It's UCSF. Hey, Jennifer. Jennifer, again, thank you so much. And she's on the architect side, and she's actually one of the architects on UCSF. And it's a $4.5 billion project. It's a 10-year project, and it's intense. And the master plan was intense. And I think that, the master plan progression that we'll be getting through the time is going to be, probably more, it would have to, go through a series of information, even at a higher rate. But let me just show, let me think here. Here's now what this is. I'm going to show a couple things here. Let me find out where it is here. Uh-oh. Well, I'll show this one. This is conceptual. This is a conceptual from a master plan. This is essentially, this was put together by, there's several folks, but again, kind of a master plan, and surprisingly enough, a lot of it is just, we don't need to look at everything, right? But it goes through all the systems quite nicely. All right, so I'm gonna stop sharing that. I want to show you what I'm really looking for, and I had it all queued up, ready to go, and I'm not seeing it on here, which is unfortunate here. Let me, let's see here. Post, well, that's, I tell you what, let me do this. Let me lessen my screen here. I had it all keyed up, ready, all ready to go here. Let me exit my screen, exit full screen, and I'll pull this up. Let's see here. It's this one. That's not it. Well, sorry, folks. The one that I wanted to show you is not there, but that's all right. Let me, it essentially had, blockings and things of that nature, but let me show you a couple other, it's pictures, So what I'm going to do is I'm going to show you some even spreadsheets and things that we get that are very common. So this here is an example of once you get the use cases. This is a hospital. So once you have, as Jabu showed on the theoretical master plan, where systems were and what does it, how does it affect habitat and what are the uses. So as an example here, you can see all of the tabs and everything, but again, not very, it's essentially, there's no cost on here. All it is square footage. What is the structure that needs to happen, the infrastructure that needs to happen? How large does it need to be, to support downstream. And this is a very simplified version, and we don't need to look at this very specifically. But I just wanted to show an example, and here is, you can see, the different departments and things of that nature. Again, it's not a moon base, but hospitals are pretty sophisticated. This comes out right out of the gate. In other words, they have a hospital with all of the supporting systems. So if you have a habitat, we know right away, or excuse me, an OR. I'll keep it on Earth terms because I'm not, many of us aren't experts on moon construction. But let's say a hospital. So if you have surgery room, the surgery room, when you go backwards, has to have all the support with it. It has to have the proper HVAC and plumbing and on and sterile department and so that's how it's put together, and nothing's volumetric. Nothing is placed on an XYZ coordinate. It's literally what needs to occur, but it gets pretty sophisticated. And then what we get is we get a lot of information from all sorts of, I'm talking about the estimating process, sophisticated estimating processes that are being experimented with here on Earth, is that we get information from all directions, from the engineer and architects and what have you. And then we start sifting through the information to start saying, okay, now how are we articulating this estimate? And again, we're moving beyond the first problem, or we're moving beyond the physical estimating, the physics of estimating, which is, how much rocket fuel do we need to lift a payload? That's given. It's easy. All you need to, you can calculate that. That's objective estimating. What we need to address is the subjective side of estimating, which is the things we don't know, but we have to account for. And a way to do that in sophistication and in very complex Earth projects is that we start going into more detail when it's a little counterintuitive. We go into more detail when there's less information, because what happens is that clarifies where we're going. So I'm going to take a pause there. I'm going to show one other, let me stop sharing. I'm going to show you one other from that information. Let me show you where we then go into an estimate itself. So out of just the master plan, this is an actual very detailed estimate that was put together. It's probably 8,000 line items with very little information. It's beyond square foot because there's no information. We wouldn't get accuracy out of, and it's perfectly low because I don't need to show you the detail. We zoomed out. But the point being, the theory behind this, and it applies to lean construction and target value design and things of that nature, is when we take all the information, we're able to put the more detailed information, the more detailed information sparks communication, sparks questions, and also it puts premise on the subjective aspects of the things that we're filling out. Filling out meaning picture, maturity, going beyond the current design. I know that sounds very counterintuitive, but if we only estimate things that we know about, it will be wrong. There will be problems, and that's just, we see this time after time. And for the new folks that are joining the team, study after study after study has shown that McKinsey study just last year, about a year and a half ago, found, if you can imagine this, 97% of all mega projects here on Earth are over budget substantially and behind schedule. Jabu?
Interested in hearing from the community about, when we think about a lunar base, there are so many dimensions here that are unknown. And there is the end states we're talking about, right? It could be a small base that's expeditionary. It could be a larger gas station. It could be a full base that's almost like a mini city, right? So there's three levels of expansion. There's also technology that's a variable here, right? There isn't one habitat design, but there are many habitat concepts. There are concepts for landing pads. So as we think about these different dimensions, both on scale and technology, I'd be interested in knowing, how do we generate an estimate that is flexible?
Yeah. I think that's good. And that ties into the other question I have is, uh, what type of information, and what type of questions would the estimating community have to fill in the gaps? So I think those two together, I think will really help. And so let's take the rest of our time and just have a discussion on this and free fall in thought. So with that said, I'm going to pick on Jennifer because she always has great things to say.
And of
What's
course,
going through your mind?
I'm multitasking. So well, it's a good question. So I think if I'm, and I apologize, I was distracted. I've got several deliverables going out today.
Uh-oh.
Yeah, it's just the way it goes. But I didn't want to miss at least part of this meeting. You were talking about like essentially, how do we know that the estimate's complete at given times?
Well, there's so
Over.
many, yeah, there's so many variables in multiple dimensions, right? There's a variable of we don't know the scale of
Mm-hmm.
the base, right? It could be a small, austere type
Right.
expeditionary base to a large city, and then technology evolves, right?
Yep.
So there are a number of different options for the concept. So, how do we, without having error bars that are, several 100%, how do you get to an estimate that seems reasonable?
Yeah, well, I mean, it's the central question um, on 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 every project, um, and I think that part of it is being, very like whatever your model is, even if it's very sketchy, like being very clear, like, we are you gonna look at options like like you're saying from, okay, first we're gonna price the bare bones, what is the austere model versus the you know the Ritz version of what this thing could be like. And the more you can identify, obviously, the various features of these things and then price them. I mean, the other way we've looked at things is like with the Monte Carlo type system is to say, okay, well, when it's really early and we don't know everything, we can look at ranges for lots of different factors within what we're estimating and see how much those might change and come up with ranges. I think so often, and I've been on the owner side and, on the architect side, and people latch onto numbers really quickly. So you tell them like, it's going to be this much or a range, and they're going to latch on to whichever number they like better, usually the lower one. And I think that for something like estimating the moon travel, it would be, or the moon construction, it would be a lot better to really start with ranges and look, for different pieces of it, and then start to kind of normalize those to, I mean, is there a budget? So what could be in and what not in, and where do we want to spend more, where do we want to spend less? But just trying to identify down to as granular as you can. You're showing on your diagram everything from waste to, these different inputs. What are the cost impacts of each of those, and then start to come up with ranges for those. And
Yeah. I think a couple things, just for context to keep alignment is, sometimes budget is important, but scientifically and for human life, maybe there is no budget for maintaining life. You know what I mean? So sometimes that value may be kind of skewed, you know, the term value may be skewed from what we're used to in earth construction. But I really appreciate the insight, because I think you nailed it. Mark has something, and it ties into what I think you were talking about, Jennifer. Mark Hilberger has a question, which is, how do we account for historicals when we don't have historicals? And so everything, because think about this, other than the International Space Station, we haven't done construction. Humanity hasn't done construction outside of our planet, again, other than, you know, and they didn't have to deal with moon riglet or landing on a surface and things of that nature. So it was probably easier construction than you know, than what they're going to have on the moon. So there's no historical, and there's a lot of theories behind this. And I would challenge maybe our students at UC Davis to start doing research, to find some research papers on this, which is how we would address pricing, well, time is cost, right? How would we account for production with no historicals? And even manufacturing. And one way to go about this, which is again being experimented on complex projects here on Earth, is to come up with more detail at the beginning, because then you have very specific, if it starts trending out, you can break things into more definitive direction. And also part of the theory, Mark, specifically to your question, is understanding we have no historical. So when we start, that's why we call it a two-way flow. So if we start with very detailed information, it's constantly running probability, and the verification process is so important. So we don't wait to the end to say, okay, were we right? We wait every second, every millisecond, to rerun probability to say we were wrong, recalculate, wrong, recalculate. And so the models are able to update much quicker. And we've talked about this before early on, which is we're not going to just show up to the base and, you know, and build a whole habitat. There's going to be test missions and things of that nature. So it's important to really understand every little nook and cranny of what happened, to build the historical information as fast as possible. We can't do it the same way we do it on Earth, because on Earth we do it too slow. And we don't have that verification that we need to give us the right information for accurate that was a mistake. It's actually true. Our historicals sometimes are hysterical. Yeah. Hey, Bob, what's your thought on that?
Listen, fascinating conversation. I like the comments in the chat. But when I think about this, and I only came into this conversation very recently as I reconnected with Paul a week or so ago. So I think I have some catching up to do. But you know, the things that hit me is you know, how do you approach this? I think is it Jabu that asked the question? Is that how you say your name?
Jibu.
Yes.
Yep. Thank
You
you.
know, how to make it flexible and stuff. And so and then Jennifer, you know, your thoughts and stuff. And what I've done on complex projects, you know, usually we have a program document. If you're in very early, you know, you have some kind of program or bubble chart, you know, some kind of programming that is the intent of the use of the project, whether it's an airport, a hospital, a high rise, whatever it is. And the way that I've done that, and it's worked well for me, is to take a systems approach. And as we look at things, we say, well, there's a lot we don't know, obviously, and there's a lot I don't know about this entire conversation. But I can tell you a lot of things. I can tell you there's an electrical system for power, just for power, for lighting and power, and the same kind of thing in buildings and stuff. And now when we get to this type of a structure, it may be an integrated, because you know the other side of electrical systems are low volt systems, and in an airport and a hospital they're very complex. We call them smart buildings, you know, and they're not nearly as smart as we're going to need to be in a base on the moon. It all has to be tied in. So, but you take that systems approach, you know, there are metals, there are frame, there's foundation. Paul mentioned some things on the moon I had never known about, and you need to consider all these things. But if you slice it into a manageable level of systems and look at it from that point, it really gives you a lot of flexibility as the concept develops. So that's one thought, and you know, I can demonstrate that on Earth models, but I think that would help. I think components and Jabu, that screen you had up, and I got to go watch. I started to look at the previous meeting video and stuff. I really want to dig in and watch that because, forgive me for a moment, but I'm a Lego guy. And has anybody gotten the moon bases from Lego? Because I bought them all. This was about 6 months ago. And I bought two of some of them because they were so cool. You could stick them together, and the rocket parts, you know, if you play with your grandkid, the rocket parts become the moon base. That kind of component approach. Somebody in the chat mentioned modular. And I understand that kind of module approach, I think, works well. And you cross that, these different comments, then you get this network of relatedness between these systems, so that if you've got a component you're going to build and place on site, whether you shoot it up there or you fabricate it on the site, but it is a component that is reusable, connectable, and that, you know, take that approach as systems format to that, because you're going to need power support, you're going to need plumbing, or you know, O2, all those systems. Looking at options, somebody mentioned the options to keep it, and there's something in lean construction called set-based design, and I rarely see it formally engaged because it's not cheap. It's complex, and it takes a lot of effort and energy resources, but you're running different designs at the same time. And I think for this exercise, you know, I'd say it's set-based programming, because you want to look at all the different possibilities that are going to come in. So I'll shut up for a minute, but those are some of my thoughts just as I get started on.
Yeah, I love your idea, and there's a lot of research and very sophisticated and complex projects here on Earth that use that are experimenting with set-based design. But I haven't heard set-based programming before. That's an interesting concept. You know,
Just the idea of moving several different concepts in early
absolutely.
phases. And I'll tell you, you know, someone mentioned stakeholders earlier. That's critical. And stakeholders, you know, if I've dealt with this in my work on mega projects, there's many stakeholders, and they should all be included. They all need to be thought about, and all of the adjacencies need to be thought through and captured as early as you can.
Yeah, and I appreciate you making that comment, and I'm pleased when I hear that comment that, you know, that the work that we've done so far as a group really accounts for that symmetrical and the integrated project approach, you know, where everyone's kind of communicating. Hey, I'm looking at the chat. There's some really good stuff here, and one is there are historical data for space stations, things of that nature. And I remember, Jabu, you gave me it was public information. You gave us, the group, an estimate for a theoretical moon base, but it was from the 80s, and I was a kick. What we decided, I threw it to some colleagues and said, "What'd you think?" And what we decided, it was we couldn't glean much information from it because it just didn't have definitions and things of that nature, and it was just a lot of stuff. But I was wondering, and I think it was Mark. It was probably Mark and Steve, where we could possibly get our eyes as a group, our eyes on the construction estimate for the International Space Station. That would be very helpful. And the reason for that is then we can see work breakdown structure, you know, how, and then we can see, okay, and then if there's any analysis of what did they have in that estimate, and what did it turn out? You know, if they thought it was going to be a one-day spacewalk to put two things together, did it end up to be two? things of that nature would be very helpful for the group, because other than that, we, we don't really have any tangible things we can point to and use as an analysis. And that would be really helpful if that's public information, and if we're able to maybe take a look at it, and we can distribute it just within the data room, and we can we can keep it just within the group, because if there's any sensitivity to it. So
Hey, Paul, this is Mark. I gotta leave at 4. I'm pinging my friend Johnson Space Center, trying to see if I can jog his memory. But he and his wife were very close to the ISS, and he's actively texting me now. So I'll see what I can do to get that information.
That'd be amazing. Yeah. That would be volumes of, just to see it and its format would be volumes of information for us. And it, quite frankly, may adjust how we approach where we're going with this structure of format of how we put the estimate together. Bob, did you have a comment? Or was that okay? All right. So, awesome conversation. And chime in. You don't have to wait for me to call on you. Please chime in. At any time. So we get master plan. Let's say this information will start coming in. Of course, you get a little bit of information, but how do we take little information and glean as much as we can for it, where we go inward, the journey and the detail and the format. Format, to me, I think, as far as how we break it out, is fairly easy. You break out, sections of a habitat and the connector and stuff, and then you have to have a section for connecting one point A to point B, another point of how it's connected, if they're modular systems, and and each component of a master plan, just like a master plan of a hospital campus, has everything broken out. You have the holistic way you look at it, and then each section is broken out separately. And then within those sections, you have independent systems. And then within that, again, you have interconnectable systems. So you have independent and ones that are connected globally. But it's not necessarily it's not necessarily rocket science. That's can be figured out. More so, our challenge is, how do we structure our questions? What type of questions would we have? Because there's going to be a lot of assumptions made. Not assumptions, as well as scope, but assumptions on what fills in the blanks. And the challenge we're going to have is that estimating and aerospace and kind of mixing, Earth construction concepts, practitioners with astronauts and aerospace and they're not connected right now. And so very early on, how do we get to understand each other better, in context of what type of information what type of questions would we ask? How would we ask it? When would we ask it? So I'm going to pause there, and because we have 8 minutes and I want to stop exactly at 4 o'clock. So I want to pause there and get some comments on some folks that probably haven't. What are some ideas? Let's just let's throw some thought out there.
I'll throw some thoughts out.
That's great. Good.
Hey, no, I've been listening to everyone, and it's interesting. Google has different types of meetings, right? Some are brainstorming, some are task building meetings and such. And so it definitely sounds like things are starting to gel, right? And you're talking about a program starting to form while the estimating team is starting to kind of understand and understand what theory to apply and what form of estimate to apply. What's our methodology, right? Um, you just mentioned something which is, I think it will be interesting to establish kind of a protocol fairly soon about how things will be run. And
Now,
then
define the word run. Define that a little more, just so I have
who's
context.
who's in charge.
Okay, thank you.
Yeah, and like
Governance.
I
Governance.
I showed you this book, Paul, How Big Things Get Done, right? Anyway, some interesting things from that book, but I definitely think we'll need some leaders and sub leaders to, and I think that's once we understand. Again, I think we still are in this brainstorming and phase. So I'm not getting ahead of myself. I'm just saying, pretty soon, all of a sudden, there needs to be some more rigor to what sort of brainstorming we're doing. So it's going to start funneling into sections, and so that's first. I think there's still a lot of that. We're talking about the right things, but also, and then there's the technical stuff, right? Like you were saying, the form of the estimate approach. Um, and we kind of need to agree on that, right? We need buy-in, and all of us have worked on large projects where you need buy-in from everyone on the form of estimate, on the reporting, on the expectation of the inputs into the estimate. So as everyone's talking, I'm kind of like getting ahead of myself. I know we're still in the brainstorming, but I'm like, I'm looking forward to maybe some um, more parameters about what is expected, and first, and then second, how what is the policy and procedure on beginning the estimate, on maintaining an estimate. So I know I'm talking, I'm kind of talking in circles over here, but I'm like, kind of, what is the form? What is the form here, right?
Yeah.
How do we get to after our kind of brainstorming and understanding program, how do we take that next step together?
Yeah, agreed. I think that's a great comment, and I think that it's also timely as well. We can either do that one of two ways, I think. I'm looking, we got 2 minutes. Um, I think what we could do is have a task group that suggests this. And then that task group maybe presents it at our next meeting. And then we discuss from there, because I think you're right. I think that will help how we ask questions and what format and stuff, because this can get really messy. It's so much information even on Earth, on mega projects. The information that we get is daunting. It's almost impossible to keep up. So and part of the accuracy of an estimate and our predictive aspect is controlling information. It is so fast in this, and there's so many entities involved. How is that even stabilized? And the theory really doesn't go into that. The information flow is more within, getting into the estimate and then how that flows. So I think, thanks, Drew. Thanks. So I think getting into that in more detail would be great. And if we had a task force, maybe I'll have Ann email everybody and see if we want to get a sub meeting together and then maybe present our finding at the next meeting and then discuss it. And that I think will get us to the next step then after that. So to be respectful of everyone's time, it's a privilege to talk to such amazing folks on this call. I mean, it's really amazing, the thought talent we have on this call, from aerospace to the private sector, is phenomenal. I'm gonna go ahead and suggest we adjourn this meeting. We'll send out an email for a task force, and then the next meeting is the task force will present what we came up with, and then we can then talk about that structure and then forward this to the next level. Sound good?
Sounds good.
Awesome. Everyone's great, and it's a privilege and an honor to have this conversation with everybody. So see you next
Thanks,
time.
Paul.
So-
Appreciate
Thank you
it.
very much, guys. Thank you.
Thank
Yeah,
you.
thanks.
Thanks.
All right. Bye-bye.
Bye.
Bye-bye. Thank you.